This is unit number 3, video 5, noble gas configuration. The configuration of electrons can get really long and tedious, and we'll find out as we go forward in chemistry from here that the chemistry of the electron is really defined by what we call the valence electrons. The valence electrons are those outer shell electrons. That's where all the interplay with other atoms is occurring, and chemical reactions occur according to that. So what we do a lot of times, really most of the time, is we abbreviate the electron configuration. We abbreviate it using what we call the core electrons. The core is the noble gas set of electrons. No, the noble gas is non-reactive. Those electrons sitting out there have a lot of energy to remove them, and so they don't go away. And so that core is going to be staying the same, very stable all the time. So we can just kind of collapse the whole electron configuration around the core and then describe the real electrons, the electrons that are involved in the chemistry of the atom. Okay? So we can see our noble gases here, helium, neon, argon, krypton, xenon, and radon. Literally an element in the next row contains that core. So an element in this row contains an argon core. An element in this row contains a neon core. And we can go on and on. So if we take an element, we'll do something simple first, like phosphorus. We take phosphorus. Phosphorus is going to be 1s2, 2s2, 2p6, 3s2, 3p3. That's the electron configuration. This is the core set of electrons, meaning all of phosphorus chemistry is in these 5 electrons. So what we're going to do is collapse that out and put in brackets the noble gas that represents. In the case of phosphorus, it's neon. So it'd be neon, 3s2, 3p3. We've done good here. We've represented the core electrons, and we're showing the valence electrons where the chemistry is going to happen. Okay, let's take another element like vanadium. Vanadium is a transition metal sitting on the 4th row of the periodic table. Being on the 4th row of the periodic table, it has an argon core. How do I know that? I go from the element up a row and then see what noble gas is on that row. Don't go down and go forward. We're talking about what's the core inside. So vanadium's core is argon. So vanadium contains an argon core. Well, I know vanadium has to have 23 electrons. That's what vanadium is. So vanadium has an atomic number of 23. So the core there is argon. Well, argon represents 18 electrons. Boom, they're gone. Then I have 5 valence electrons I need to describe. What row of the periodic table is vanadium on? It's a 4th row element. Every row starts with the S. Get that in your head. Every row starts with the S. We're talking about ground state neutral atoms. Okay? So we're on the 4th row. 4s2, vanadium's 23, argon was 18, therefore I have 5 left, so 3d3. All right, one more noble gas configuration. Let's do something really big, like lead. Lead has an atomic number of 82. Here's lead sitting in the P block. It should end in P2, P1, P2. Okay, which P2? Well, 1, 2, 3, 4, 5, 6 P2. This is the 6th period on the periodic table. The core inside of lead is xenon. So I'm going to have a xenon core. Xenon is 54 electrons. Therefore, I need to describe 28 electrons. Lead's on the 6th row of the periodic table, so I'm going to start with the 6s. After the 6s, we can see here, this is where our F begins. The first F is in the 4th energy level. Okay, N equals 4, L could be 0, 1, 2, or 3. We know L equals 3 is the F. So we have a 4F here. F has 14 electrons because there's 7 orbitals. 4F, 14. That gives me 16 of the 28 electrons. After the 4S comes the 5D. 5D, 10. That's 26 of those electrons, 6p2. So the noble gas configuration gives us an abbreviated form, actually more useful form, because it emphasizes the valence electrons. The valence electrons are where the chemistry is going to happen in the atom.